Okay, now that we have our first flange and stem piece for our first part completed, we'll go ahead and move on to the second part, which is going to be the center spacer. I've got it listed as part 3, but this is just the next one in line that I'm going to work on. So this one will be fairly simple. We'll chuck it up in the 3-jaw. We'll go ahead and face it, drill it, counterbore it, and once we get all that finished, we'll flip it around, make sure it's trued up nice. Go ahead and face it to the correct length and remove all the sharp edges. All right, so let's go ahead and get this one machined now. We'll start by facing one side off. That is about 100 thousandths oversized, so we'll just touch off and take 50 thou. Tell you what, I'm gonna go up to 900. There we go. $50 thou is always a good round face cut when you're trying to remove some material. 10 thou feed rate. Now we'll go ahead and get our hole drilled through there. Now we'll go ahead and knock that corner off while our tool post is where it's at. Get rid of that sharp edge. For our drilling, we'll start with a center drill just to kind of spot it. And then we're going to go in with a 1/2 inch split point drill. And then we'll follow in there with this 1 1/4 inch taper shank. Put an 1 1/4 inch hole in there, and then we'll just bore it to our 1 1/2 inch size. I think I'll go ahead and use our flood coolant for the drilling op, just kind of keep everything nice and cool and keep the cutting tools cool as well. All right, let's see if we can do this without making a huge mess. That's making the mess is one of the reasons why I don't always like using coolant over here on the lathe, but for drilling ops, it's perfect. As long as you're not spinning the chuck too fast. I got it set at 340. See, even that, see what I mean? Even that is trying to sling it, and it gets all over the floor and the toolbox over here. Let's see. Let's see what we can do with that. I don't want to go any slower than that. Drill's cutting beautifully, even on both sides. It just wants to make a mess. And it's over here on my print, dang it. Just use flood coolant, they say. There we go. All right. Well, there's our pilot hole. All right, we got our 1 1/4 inch loaded up, and we're going to run this at 180 RPM. Let's get some flood coolant going. Let's see how that looks. Yeah, not bad. Slow that down just a little bit. All right, we got us a boring bar set up. Let's see what our hole size ended up being. I cut very true. Look at that, 1.252, 253-ish. Nice. So we're going to bore that to 1.502. Let's see if we're around 1 inch 452. 1 inch 450 and a half. All right, so we've got about 51 thousandths to come out of that. So that should have been our finish pass. We got a nice finish in there. We sped that up to 900 RPM and run a 5 thousandths feed rate on that. Let's go ahead and get us a measurement using our telescoping gauge. The target is 1.502. And let's see what we hit here. All right, 1.501 and 5/10. .501 and a half. So I'm a 1/2 thousandth smaller than my target size, and there's nothing wrong with that. A 1/2 thousandths tolerance is well within line of what we're shooting for here. So our bore is finished. Now we just need to do our counter bore. So now we got to do our counter bore here. You can see we have a depth of 0.25, so 1/4 inch deep, and a diameter of 2 inches and 2 thousandths. And that is what is going to line up here on this little registered fit that we put on the first part. That's going to line those two up together and make them fit good. So we want to try to hit our target there, 2 inches 2 thousandths, and then the depth there, we'll be able to do that no problem, 250. So let's get that machined. Another really good use of our carriage indicator right here. You guys can pick these up from Edge Technology. You got some magnets, and when you stick them on the ways there, it keeps the stem of the indicator parallel in line with the travel. And what we'll do is just set our stop there. So let's come on up with our boring bar. I'm going to get myself really close and just very lightly just touch the tool to the face. And I'm going to set a 0 on my Z-axis DRO. Now I want to come up. I can see how close I am. Just touching there. And now we can go ahead and I'll just re-zero our DRO We're going to go in there. I'm going to go in there 240 thousandths. All right, and then we're going to set this guy to our first 0. And the way it's clocked, I like it to come on around to about the 3 o'clock position. You need to give yourself a little bit of run-in time. So when you see that needle start to move, you're not hurrying to stop it immediately. You want to be able to watch it come around to your 0. So, and that gives us 10 thousandths to clean off that back face there. It also allows you, so as this is coming up and feeding and you're approaching your 0 and maybe you don't hit the lever just in the nick of time and you might go past it a little bit. That happens. It's very common that you might go past it a few thou. So that gives us 10 thousandths to clean that face up. All right, so with that, I think we're ready to cut it. So I'm going to come in here and touch my bore. Just go ahead and touch it right there, and I'm going to go ahead and zero out my X on the DRO and just start from a 0 point there. That was 4 passes, so we should be pretty close, 1.9-ish. Yep, right around 1.9. So 100,000 still to come out. We'll just go ahead and take, let's take half of that now. Go ahead and take 50 thousandths, and then we'll make a couple more passes there. All right, we know we got another 50 plus. So for this cut here, I'll tell you what, let me get that, pliers are never around when I need them. Yeah, just trying to get rid of that guy there. All right, let's take 25 thousandths, 5, 10, and 20. And then we'll start doing our precision measuring from here. So there's something that I forgot about here, and I was jumping ahead of myself, and that is there's a small radius in the corner there, and I've already bored it up so close that we can't go in there and cut that radius and it clean up like it needs to be. But we're still thicker. We still have material here of about 50 or 60. Yeah, so we still got a 16th right there, so that's perfect. So what I'll go ahead and we'll go ahead and finish doing what we're doing here and get our bore finished and get our radius machine in there, and then I can just face this off to the proper depth of 250 thou, and then that'll still give us enough room once we flip this around to just skin that other face clean. So I'm going to go ahead and swap this insert out. What we're going to do is we're going to remove this insert here, which is a 431, and we're going to go in with a Walter insert, a 433 size. So that is about a 16th corner radius on the insert. So it's a little smaller than what we actually have on our print, but we're going to use this because this is going to be fine for the radius that we want to put in that corner. That'll be so whenever this is molded, the bushing, this corner right here on this insert will actually be the corner of the flange that gets molded in there, and that's going to work pretty good for that. I'm going to go ahead and get that extra facing material out of there now. Not going to have good chip control with this big nosed insert. All right, there we go. That's going to be our back face that we're going to go up to. Come back to our 0 on our X. Come on. Which one were we at? Right about there. All right, Let's take 10 thousandths on this guy and see what happens. Of course, it's going to try to chatter on me, so we'll have to fix that too. Slowed the RPM down to try to eliminate that chatter, and it's definitely helping. So I think we've got a good process there to process of elimination. I am going to use a telescope gauge here to check this. We have just enough material that we can get a good contact on both of the tips. And we should have about 7 or 8 thousandths, I believe, to come out of this. 996, so that's 5 6 thousandths. 6 thousandths. I'm going to go ahead and double check that. It's really easy to get it wrong. See, if you move that telescope gauge too much and not stay dead, top dead center. So we'll make another. Need to have resistance whenever you come out of it so that it straightens itself up. I'll come back in here and check this again. Getting the same thing. $996 thousandths. 5 6 thousandths is what we want. All right, well, it cleaned up the corner nicely. Let's see if I hit my target size. .002 and 3/10. So 3/10 over. I still think that is perfectly fine for what we're doing here. You got to give yourself some kind of tolerance to work within. And I think a 1/2 thousandths is more than suitable for this kind of work right here. So we're just going to go ahead and double check that again. All right, 2. I got 4/10 that time on that, so we're still less than a 1/2 thousandths over our target. Let's take our first piece, and it fits in there. Fits in there. We have this. There's a rolled edge. That's what's throwing me off. It's got to be deburred, but I can tell that it's fitting accurately. We just got to get it deburred is all. We're ready to come in here for our corner chamfers there, using a piece of high-speed steel. This is a tool that I grind. I just use it for chamfering. I went ahead and re-honed the cutting edge there with a stone, so the edge should be nice and sharp. wanted just enough chamfer on that corner to clear the radius inside this little registered fit there, so it would seat all the way up to the face, and that's what we got. I can feel that couple thou clearance in there, and we have a good fit. Once again, I was jumping ahead of myself here because I knew that I needed to face this off, but yet we chamfered it anyway. So we're gonna have to come back and chamfer it because I need to take a little bit off of that. So we've got our depth mic here, and I'm just gonna go ahead and get a read in. So we want this to be 250 thou. So right now, let's see, where's 250? There's 250. So there's 25 thou, 30, 35, 36, 37. So we need to take about 37 thousandths off of that face right now. Just going to go ahead and work through this. Touching the face there. Get a 0 up there. Let's get a 0 on our dial indicator. We'll just go ahead and take 25. Leave the tool right where it's at. Let's take us another measurement and then take a finished cut. Get rid of those chips. It's about 14 and a half is where it's touching. 14 and a half. Okay. Looking down here on this dial. 5, 10, 14 and a half. Let's see if that's it. Again, let's just leave our tool right there. I don't want to drag it across the face, but I want to check this before we move it and see if we hit our target. I think we did. It's probably going to be just a little bit of material rolled over from that facing cut. And we are 0.5 thousandths off of our depth right there. So we're going to leave it right where it's at. There's nothing wrong with that. And I'm going to go ahead and just re-chamfer that inside corner. Already chamfered that inside. We're going to go ahead and hit this outside corner, break that sharp edge off of it. Just like that. And what I'd like to do is take my Scotch-Brite. Let's give it a nice little hit with some of this right here. Just kind of polish it up. It always softens the edges and then makes the surface finish look a little more smooth and bright. So that looks good. That looks good. So I think this side of our sleeve is now finished. We'll go ahead and take it out, flip it around. We'll use our mic and go ahead and get it faced to the proper thickness of 1.25 inches. See if we can get it in here and get us another measurement. Looks like 13. Do it one more time. $13 thousandths. That's what we need. Too much surface speed, not enough depth of cut. That's why it tried to roll that chip around. Luckily, it did not scratch it. because that was my finished pass, but that's usually when it wants to do that, right? On your finished pass, not on the roughing passes. Looks like we hit 250 on the nose. Nice. 250. All right, that is good to go. Only thing left now is that we need to put our chamfers on there. We just want to kind of break the outside. Just kind of matching the other side. That looks good. And then we'll swap our tool and do the inside. All right, this guy is finished up. Let's get it out of the lathe. Okay, so we've got the first and second pieces finished right there. Everything's turning out real nice, so now we have our third and final piece that we got to machine, and that's going to be the cap. So we'll take this disc over there and go ahead and start on it. So this one's going to be fairly simple too. I think the trickiest part really is going to be just lining it up, which ain't going to be a problem. And then one side has that registered fit so that it'll line up down inside this bore here. And in the center of it is bored 0.752, give it about 2 thou clearance over this stem coming through there. And we'll have a couple holes drilled in there as well. So once we through the lathe work, we'll have to go to the mill and put a couple holes in it. So let's get back over on the lathe and get started on this guy now. All right, so there's a few ways that you can put a thin disc in the chuck here and get it to run true. And I think the trick that I'm gonna try here is to just get lucky, really. Let's get it. Usually when you have a good piece of material like this chrome plated rod, it's pretty true on the outside. So a lot of times you can actually take this and just actually feel the material squaring up on two of the jaws and just kind of hold it against those two and then snug it down. You can also, sometimes it might move a little bit when you go to chuck it because you're kind of pulling it one way or the other. If you just unchuck it and then just let it settle on those two jaws, it'll kind of square itself back up. And we'll go ahead and snug it up. Let's see how it's running. That's running perfectly true enough that we can get in here easily and face that guy, no problem at all. So we got lucky then, but we do need to make sure that it's tight because I didn't fully snug that up. So let's go back to our chuck and just go ahead and make sure all three pinions are snug. All right, and then we are ready to roll. So that material actually burned up the high speed, so I put a carbide tool in there. We're just cutting a chamfer on this. There we go. So we got to make a 3/4 bore through there. We're going to drill it and then bore it to size. So we're going to go in there with this 23/32. This is my Chicago Latrobe. This one is still new. Should cut nice. It's got the 3 flats on it, so we ain't got to worry about it spinning. So we'll get this through there, and then we'll put up a little boring bar and get it bored to size. Using some of our anchor lube here for the little bit of drilling that we got to do. Put a little bit in the hole, a little bit on the drill here. I'm going to use my Micro 100 Micro Quick boring bar here to bore that to size. I love these little tools because the way they've got these made, you got that angle ground on the back. Inside the holder, there's a pin that squares it up. So really all you have to do, you can see that notch on the top of it, is you install it. If you get it straight, it's a very precision fit. You stick it in there and that pin is actually going to square up the end of the tool right where it should be. And you just tighten up that set screw. That's a conical shaped set screw that just locks it in and keeps it pushed back. Got 10 thousandths to come out of there. I just took 5 thousandths because I'm going to go ahead and mic that again and we'll make a finish cut. Get a measurement, see what we landed on. That's looking really good. 752. Maybe 1/10 over. That's nice. All right, so tell you what we'll do. We got our part that's where it's gonna fit over. Let's check it. Yep. Nice close fit on that, just like it needs to be. Nice. Chamfer on that side will be finished up. All right, we'll get this guy out of here and then we'll chuck it back up. So I'm gonna have to come up with some spacers that we can push this up against so that it'll not have a nice parallel cut to it. So we'll just need to clean the chuck a little bit and then I'll show you how we're gonna do that. So I've got several of these Edge Technology chuck parallel systems right here. And all they are 3 parallels that's bolted to the spider, and they got some magnets back here. This is just a spacer to keep it centered in the chuck. And these are 1 1/8" tall. You can stick these guys on here like that. Now, the problem is that these aren't actually tall enough. And I have a set of the parallels. The tallest ones you can get in it is this guy right here. Let me see, 1 3/8. I think that's the, I'm sorry, 1 5/8. So you can bolt that on there, but you see, we really only have a little bit that we need the chuck on because we need to face this to our proper thickness. And even going with the thickest parallel, it's still going to be up in there, so that's not working real well. So what we'll do is just find some parallels, or maybe even a 1, 2, 3 block or something. I need to get something in here that's going to shim it off of these parallels out to about right there. We really only want one notch of the 3 jaws to hold that, so we can get it faced off. So where's my rule at? Let me get a measurement. I'm thinking one of my magnetic shim blocks from the Fireball. Yeah, so I think 1 inch will probably work to shim that out. So we'll try that. We'll put our little magnetic blocks here and see if we can push it up against it. There we go. This is what I was looking for right here. And we could actually go in there a little bit further, but I think this is going to work right here. So let's go ahead and push that in. And tighten up our chuck jaw. I wasn't on the pinion I wanted there. So that's got a good feel to it. It should be good to go. We'll go ahead and we're going to pull these guys out. We're not going to leave them in there. This is going to stay in there. We can't get it out, but the magnets will hold it in place. So let's give this guy a spin up and see what we got. That's looking nice and true. I think that's going to be good. So we use our mic and go ahead and measure what our thickness is here. Overall thickness is going to be 300 thousandths. The flange portion is going to be a 1/4 inch, and there's going to be a 50 thousandths wide register there. So we've got about 70 to 72 thousandths that we need to face off that total. All right, so just have one more pass to clean the face up to our 300 thickness. So we've got 25, 35, 6, 7, 8, 9. 39 thousandths to come off that. All right, we've got our Z set to a 0. Just give that a quick check. Make sure we hit our size. We should be. And then we've got to face our register on there now. Yep, it's 300 thousandths thick. So the length of our little register fit is going to be 50 thousandths. So we'll end up going another 50 thou deep on that face there. Put some blue in on here so we can see everything well. Let's go ahead and get rid of that bird that's in there. We're going to chamfer this. I just want to get rid of that so it doesn't make it look weird in there. My insert needed to be indexed there. It was trying to rub too much, so we swapped that around. We're going to try to clean that face up again. We 2 or 3 thousandths off of it. So that fit right there is what lines up inside this piece. Got a good fit on that. So it should have about 2 thousandths clearance over that bore there. So we're on to our last step here for our flange piece, and it's going to be very similar to what we did right here. So we're going to use this 1/8 wide full radius insert, and we're going to plunge in 35 thousandths, and just all I'm going to do is actually just blend or cut all the way up right up to the edge of both the bore and this registered step right there. But it's going to be just like what we did on our very first piece, like that. Go ahead, another 10 thou. Okay, we have all this polished up nicely, nice and soft, smooth, no sharp edges. All right, there is our flange piece. Here's our center bushing, sleeve. Fits on there nicely. There we go, look at that. Beautiful. Our machine work in the lathe is wrapped up now. We'll go ahead and get it out of the chuck. We're getting into our home stretch. We're almost done. So the cap that we just finished here is nearly done. We just got these 2 holes to drill. So we have 2 1/4-inch holes. 1.5 inch bolt circle diameter. So we'll go set up this in the KBC mill and go ahead and get those 2 holes drilled. So I'm liking the way everything is coming together. It's got a nice fit. I did manage to put a scratch on there from pulling out one of these magnetic blocks. Must have had a burr on it somewhere that I didn't check for, and whenever I pulled it out, one of those edges scratched it right there. So that's unfortunate, but it's the size, so I've already tried to polish a little bit, so it's fine. It's just a cosmetic thing, but man, the fit is looking good on this guy right here. So let's go to the mill, put our 2 holes in it, and that'll wrap up this job. All right, we got her set up in the KBC mill, and this is a perfect example of why I machined this fixture plate. This is one of the older, no longer being made Fireball tool fixture plates, and I had machined this several years ago. This is a project that I put on the channel. I made a steel base plate for it, so made for exactly things like this. So you can take this, clamp it in a mill vise, and be able to easily hold and secure and fasten down small or odd shaped parts. Okay, so I got this little clamp kit right here, and this was actually made for me by one of my viewers. It was Paul Boulay out in Campbell, California. I believe he had made a few of these kits and sold them at the time. So this is several years back, but we got different strap clamps in there, studs, bolts, some pins. I got some dowels in here because we have a 1/4-inch dowel reamed holes, which I've milled that, so they need to be chamfered again. I've welded on this. So this was really mainly going to be sort of like a universal fixture for welding and machining. Last few jobs I've done on it, I welded. That's what the discoloration is. But you've got plenty of thickness there, so really all you have to do occasionally, if you want to, is just deck it off maybe 5/1000ths with a face mill and clean it all up. It's a good idea to do that when you set it up in a machine. That way you know you got a good parallel surface there. But for drilling some holes, you don't really need to do that. But anyway, I love pulling this kit out and the fixture plate there and showing it to you while we're using it for our project. So we are all set up to go. We'll get a coaxial indicator out, sweep that bore, and then all we got to do is drill our 2 holes. Okay, we got our Blake coaxial indicator set up here. Got a stop rod back here to keep it from spinning, and all you got to do is just move your XY to line that up on 0. So I used a 1/4-inch spot drill and then a 1/4-inch split point drill there to put the holes in it. But the holes are so close to our radiuses right there. I mean, they come right up to the radius. So I don't want to put a chamfer tool down in there and cut into those radius. So we're just going to leave that alone. I'm going to try to just very gently hand deburr those holes with a little Noga scraper. So we're all finished up here in the mill. We're just going to go ahead and take it out now. Just use our little Noga deburr tool there. All right, guys, well, this is gonna wrap up this project. This is complete on my end, and it's ready to get packaged up and sent out there to Justin in Las Vegas. So we have our 3 components here. We have our cap, we have our center spacer right there, and then we have our flange and stem piece, that guy right there. I think it turned out good. I think it looks good, and I'm pretty sure that I hit all the tolerances well within what Justin was asking for on this. The only thing I don't like is the fact that I got that scratch in it right there, but you can catch it with your fingernail, meaning that it's probably 2 or 3 thousandths deep. You'd have to face that off in order to remove that scratch, but it's just a cosmetic thing. That's all it is. That's the outside, so it's not going to affect anything. But I really do like our fits that we got on here. A couple thousandths clearance on those little registered flanges, and that's going to work pretty good, I think. Hopefully it will. So just to kind of quickly go over how he was going to use this again. So he said he's going to put a bolt through there. I guess he'll have to have him a washer, maybe notch it to clear the 2 holes, but he's just going to use a bolt and a nut to hold the whole thing together. I think it's just going to be a bench setup just like that. He says there's some kind of syringe that's going to have the plastic material that he's going to be using to make the bushing, and basically just inject it in those 2 holes right there until they come out of that hole, and then let it solidify. And then once you do, you should be able to take this apart, take that off, and you should have a bushing sitting right there, a negative of this piece right there. And I don't know the specific applications at which he's planning on using these bushings for, but I know he has some ideas, and this is just going to be a prototype for this size here. And I believe that if this works out for him the way he wants, and it's something that he can actually sell, he'll probably have some other sizes that he's going to want to come up with a mold like this for different size flange bushings. So he'll be probably a little more specific as to what he's going to be using these bushings for, or what they can be used for, because it's supposed to be a universal application that you can buy and for different fabrication jobs, things like that. So be sure to check him out. He's on YouTube and Instagram under the Fabrication Series. Great guy to know. I'm glad he's a friend. We talk every now and then just on shop stuff, projects, business, and things like that. Sometimes I'd text him and ask him how the world's going out there in Las Vegas, and we just kind of chit chat about stuff like that. But anyway, this job is done. I'm happy with it. I hope Justin likes it, and I hope you guys enjoyed watching the videos and following along with this project. And hopefully he'll have a follow-up on his end on actually making some bushings and the finished product once he gets his hand on this. So we're going to get this packaged up and send it out there to Las Vegas. So I hope you guys enjoyed, and I hope to see you here on the next project. All right, see you then.